Hi, everybody. Thank you for coming to my talk today. My name is Scott Churchill. I'm the Vice President of Scientific Development at MCR Labs. We do compliance testing for cannabis and cannabis products. We're going to be taking a look at an evaluation we did on the impact of a growing environment on the production of secondary metabolites by cannabis plants. In addition to being the vice president here, I'm also one of the founders, and this was my first company where I was part of a startup, and a number of the experiences I had, I consider to be stressors, and those stressors, as I was going through that, forced me to adapt by developing new techniques, greater knowledge base, resources for dealing with a variety of things. And that kind of is what we're looking at today with plants. If we have, different stressors, do we get different responses from the plants? So when you think about cannabis cultivation options, you have indoor and outdoor, you have greenhouses, and all of those different environments have different things associated with them. And indoor grow allows you to control a lot more tightly all of the variables that the plant will be facing. It also allows you to have a perpetual harvest, and you're likely to be able to better control microbiological contamination indoors and prevent any kind of accidental exposure to pesticides from a nearby farmer putting down pesticides on their crops. But it is more expensive, and it is a heavier impact on the environment in terms of the lighting and the heating and the cooling and the control of the environment overall. So on the outdoor grows, you get free sunshine, you get free rain, and you have less expense associated with trying to scale a grow. And there's a lot of good reasons, but you need the right environment, and you don't have as tight a control over some of the variables that we mentioned. A greenhouse is a good compromise, and to the extent and to the way you leverage it, you can get some of the benefits from both indoors or outdoor growing. But what is the impact on plant compound production between these different? That's the question we're going to be taking a closer look at. But when we look at that, we have to take into account that there are a lot of different variables that affect what a plant's going to produce. The first and most obvious one is the plant genetics. You have some plants that have been selectively bred for a period of time to produce either high THC numbers or high CBD numbers or some kind of ratio of the two. People are looking at cultivars specifically for CBG or other types of cannabinoids. They're selectively breeding them to turn off or on things. And when you do that, as you continuously do that over time, you start to trim the branches of possibilities of those plants and what they can produce. Other factors that could affect the plant's production of secondary metabolites is nutrition and irrigation, lighting, whether it's indoors with a limited spectrum and tight control over time and intensity, or outdoors where the intensity changes and the time changes depending on the season and where you are and the orientation. Indoors, you have a lot more control about centering the light on the plants, whereas outdoors, you have to pick where you're going to put your plants and let them take advantage of the sun that way. So our hypothesis was that we could control for the genetics by taking clones with the same genetic information and use that control to see if they express different secondary metabolites as a function of their growing condition. We did this by enlisting 3 cultivators who had a total of 5 different cultivars, And for each cultivar, we took a clone and we split it between indoor and outdoor growing environments. We had the cultivators then take it through vegetation, flowering, drying, and curing to a finished flower product. And then they brought the samples to 2 laboratories for analysis. In the 2 laboratories, one of them was mine, we employed a targeted quantitative analysis where we do the compliance testing. So we test for all of the usual compounds, 17 cannabinoids, 23 terpenes, 4 heavy metals. And we do that using LCUV, GCFID, and ICPMS. Our partner lab that collaborated with us on this was SciEx, and they used a QTOF. They did an untargeted search where anything that ionized, they collected spectra on, and then would do an analysis of, well, they did 2 things. One is they did principal component analysis to see if there were categories of compounds that were unique to indoor versus outdoor, as well as being able to take some of the spectra that were obtained for the different growing conditions and compare it to a library to get a pretty good idea of what we were looking at. So we're going to take a look at the results. We're going to summarize the overall findings, then we're going to look a little bit at the quantitative results, followed by the qualitative results, the untargeted search. The results show what we were expecting to find, which is that the trends show higher secondary metabolite production in outdoor grown plants. The untargeted shows not only that the compound secondary metabolites were elevated in the outdoor grows, but the type of compound produced in the outdoor grows was different, had a different chemical profile than the indoor grows. We also observed that there were strain-specific trends. This is where the genetics of the plant had a greater impact on what they produced versus the environmental conditions, whether it was indoor or outdoor, did not have as high an impact. We also took 2 of the cultivars, a total of 4 plants, indoor and outdoor, and we did heavy metals analysis on it. And we had a interesting finding there where in both cases, the indoor samples showed detection of cadmium where the outdoor samples did not. It's a very limited data set, and we're going to have to take a closer look at that down the road. This table shows that in 5 out of 5 samples, the terpenes and the CBGA in the targeted search were elevated in outdoor grown samples over indoor grown samples. In 4 out of 5 cases, delta-9 THC, which is a degradation product of THCa, was elevated in the indoor samples, and in 3 out of 5 cases, THCa was higher in the outdoor samples. We also, like I said before, saw that there was cadmium detected in the 2 indoor samples as compared to outdoor samples that we looked at. This is the principal component plot for the indoor-outdoor differences, and this is just showing you that the principal component 2 is consistently elevated in the indoor samples and depressed in the outdoor samples. This is a breakdown of the different analytical targets that created those principal components. And we're going to be taking a look a little bit later at some of the targets that were identified to be associated with outdoor grown samples. And this is where we got those targets from. This shows the unique strains where, Field Trip number 9 and Starfighter both their chemical profiles, whether they were grown indoors or outdoors, did not dramatically change how their secondary metabolite production was geared towards. So they are examples likely of selective breeding kind of minimizing how much variation you can expect by varying the environment that you're growing your plants in, the inputs. And this is an example of one of the outdoor associated targets that we identified. It's got a mass to charge ratio of 271, and on the left-hand side, you can see it's always elevated in outdoor and never elevated on the indoor. And on the right-hand side, that's just a plot that allows you to see the difference between the outdoor a little bit easier. So we did a library match to this, and it matched up very well to apigenin. This is a compound that's of therapeutic interest because of its antioxidant, anti-inflammatory, and blood pressure reducing characteristics. It's also antibacterial and antiviral. So it's being looked at for a number of different applications. It might be important to have plants that express this if that's something that you're trying to accomplish. And it's heavily biased towards producing more of it in the outdoor samples versus the indoor samples. Now, on this one, we see the same trend. It's an unknown with a mass to charge ratio of 433, and it's always elevated in outdoor. It's hardly detected in the indoor samples. And we did the library match, and it turns out that it's Vitexin. Vitexin is also got the therapeutic potential. It's they're hopefully looking at it for potentially modulating hormones, reducing the severity and the symptoms of PMS, and they're also looking at treating migraines and joint conditions with it. The trend continues with this: outdoor always elevated, indoor not really present, and it turns out that it's a sugar conjugated version of Vitexin, Vitexin rhamnoside, and it's also being evaluated as a potential therapeutic. I didn't see anything specific for that alone. I saw it mentioned in studies that were looking at flavonoids in general, which is a hot topic in plant therapeutics. And then we also saw an unknown at 449 mass to charge ratio. Again, elevated in outdoors, not present so much in the indoor. And it was a library match for orientin. That's being looked at for anti-aging and anti-cancer treatments. And I didn't mention it on the previous slides, but if you look at these compounds, they are very oxygenated as compared to the typical terpene profiles. The outdoor grown samples tend to have more oxygenation. They tend to have more sugar conjugation. They tend to be larger, more complicated molecules as a differentiation between the indoors and the outdoors. So, and then, you know, in some instances that I highlighted here, they're compounds of therapeutic interest. So going back to the variables that we talked about, you know, indoor versus outdoor, and the fact that we did see, you know, 2 strains that had heavy metals detected in the indoor, we don't have enough information to know whether or not feeding or water source was the cause of that. So that's something that we're going to try and look at a little bit more carefully in a separate study. But we were able to see an increase in the amount and type of secondary metabolites produced in outdoor samples versus indoor samples overall. And in the outdoor samples, we were able to identify principal components to separate indoor versus outdoor. The indoor samples were biased towards producing the more common, routinely measured, lighter, simpler terpene type secondary metabolites, whereas the outdoors had the larger, more complex molecules being produced in the outdoor samples. So we also saw that some strains do not respond to the different environments that they're in. They basically produce what they produce, and you could do it indoors and outdoors and get very similar results. So very, very interesting findings. I think that in conclusion, the cultivation method does impact both the type and amount of secondary metabolites that are produced. This phenomena can be somewhat diminished by specific strains. My current theory is that it has to do with how much selective breeding has gone on and how much the options of the plants have been trimmed out by those breeding programs. And of interest for further studies is trying to identify which environmental conditions from the outdoors are reproducible indoors. That way, you would be able to put in the appropriate conditions to get indoor grows to produce the secondary metabolites that might be of therapeutic interest. That could be important in places where you don't have outdoor growing as an option. And it will be important if you want to have perpetual harvest, if you want to have tighter control over microbial contamination. But nevertheless, the fact that the production of metabolites is impacted, this means that when you're making decisions about your grow, you have to factor in addition to all of the factors that we talked in the beginning, in terms of the cost and the control that you get and the freedom and so forth, you also have to ask whether or not you're attempting to produce these molecules of interest. And until we can find a way to tease out the outdoor conditions that result in those molecules, outdoor is the only way that I'm aware of that you can kind of put the plant in a position to make those molecules, or favor those molecules at least. So for future studies, that's what we're going to be looking at, as well as taking out a separate study to look at heavy metals and whether or not there are conditions that are in the outdoors versus the indoors that are impacting whether or not they take up heavy metals, and seeing if we can identify those as a possible way to prevent those types of accumulations. And with that, I want to thank everybody for your time, and I want to let you know that if there are any questions, you can reach out to me. I'm at scottc@mcrlabs.com, and I'd like to hear anything that you guys have to say about this or any questions that you might have. Always looking for opportunities to collaborate with the community and answer questions that otherwise can't be answered without access to analytics. So in addition to the compliance testing we do, we try to add in experiments and initiatives and collaborations that allow us to answer questions that are important to the community. With that, thank you and have a great day.